We're looking at a linear application. We'd like to figure out a linear function that will solve this problem. The median age in the U.S. in the year 2000 was 35.3 years, and it increased on average by 0.07 years per year. We want to write a function, a of x. X is going to be our year, somewhere between the year 2000 and the year 2050, to estimate when the median age will reach 37 years. Now we need to take a look first at what information is given to us. I have two things. They told me that in the year 2000, the median age was 35.3 years. So what they've given us here is an initial value, a point. X is the year 2000. Our y, or in this case, a of x we'll call him, is the average or the median age, 35.3 years. Fishing through our information, not only did they give us an initial value, they told us that it increased on average by a certain amount, this 0.7 years per year. And notice this is a rate of change. Because it is a rate of change, this we can assume is a linear function. It was a constant rate of change. This is going to be our slope, and for our function, our slope is given as 0.07. Well, they've given us a point, they've given us a slope. Let's use point-slope form. First, notice the fact that the constant rate of change was given led us to use a linear function to model this data. Point-slope form, we have the form y is equal to our slope m times, we're looking at our x change first, x minus x1, plus our y value, our initial value, y1. So to create our function, we will have our function a of x is equal to our slope 0.07, x minus, from our initial value, we have our x value of 2000, plus our initial y value, which was our 35.3, point-slope form of line. Now, if you choose, we could also write this in slope-intercept form. Usually the point-slope form is sufficient, but because we plan on doing some work with this function, we still need to solve the problem. We could switch it up and use our point-slope form into our slope-intercept form. We're going to be distributing, so we will have our 0.07x minus 0.07 times 2000, which will be 140, plus that 35.3. So our linear function in slope-intercept form, 0.07x, 700x, minus 104.7. We have our function. Now we can take a look at solving the actual problem. Since we're looking to estimate what year, the median age will reach 37 years, in order to solve this problem, we just really want to know when is this linear equation, 0.07x minus 104.7, going to be equal to 37. And solving our equation, simply adding to both sides. Don't forget to line up that decimal point, kids. 0.7x is going to be equal to 141.7, and finally dividing through in order to solve, we end up with x being equal to 2024, with a little bit of extra stuff here. For us, we were looking for a value of a year, so we know that in the year 2024, the median age, that's when it's going to reach 37 years. And we're done.